All right, section 4-6, graphing other trig functions. Today's lesson, we're going to graph tangent, then cotangent, and then we're going to get into the cosecant and secant. Tangent and cotangent are a little bit different than the other ones. They have their own shape, their own picture. Secant and cosecant are going to be reliant on you being able to graph sine and cosine. So the homework that was due for this section, hopefully we understood it, and it's going to make a big, big difference when you graph a secant and cosecant. All right, to graph a tangent of theta, we know that the tangent of theta equals the sine of theta over the cosine of theta. That's our cofunction identity. Not cofunction identity. That's our quotient identity. All right, so the tangent of theta is undefined when my denominator equals 0. When my cosine of theta equals 0. So we need to think on the unit circle, where is the tangent of theta undefined? And our thought process needs to be the tangent of theta has a denominator of cosine, so that means I need to know when my cosine equals 0. I need to know when my tangent of theta, which is y over x, is some number over 0, which is my cosine. If I go to my unit circle, at the top and the bottom are where my cosine equals 0, my x value is 0. So we're going to say that tangent is undefined when theta equals your pi over 2's. That's the top and the bottom of my graph. All right, so theta is going to be, tangent of theta is undefined when your theta equals any pi over 2. All right, that's when the cosine is 0. All right, we're going to change it up last time. All the other functions, secant, cosecant, cosine, and sine, have a period length of 2 pi. Tangent is going to be pi over b. All right, tangent and cotangent are going to have period lengths of pi over b. It's going to take half the distance to go through all your possible answers. All right, so looking at number 1, I'm going to ask you to graph 3 periods, 3 pieces. Y equals the tangent of theta. The first thing I'm going to say is my period length is pi divided by my b value, which is just 1, which is pi. Because theta is that variable. All right, so what we're going to do next is we need to find 4 consecutive places where my tangent is undefined. Okay, that's where we're going to have some vertical asymptotes. All right, tangent is undefined at all of our pi over 2's. So we're going to find 4 consecutive asymptotes. So what I'm going to do is I'm going to take this value, my theta, what I'm taking the tangent of, and set it equal to 4 consecutive places where my tangent is undefined. Again, my pi over 2's. And we're going to use negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. Those are going to be the 4 that we set this, what I'm taking the tangent of, equal to. Those are going to be where I'm going to have 4 consecutive asymptotes. All right, so I'm going to come over to my graph, and I made this one pretty long in both directions. So I'm going to count out these asymptotes. I'm going to go to the left, negative 1 pi over 2, negative 2 pi over 2, and negative 3 pi over 2. So I'm going to count out negative 1 pi over 2, negative 2 pi over 2, and negative 3 pi over 2, hopefully about the same distance each time, to the left. And then, because it's all based on this, I'm going to go to the right, pi over 2, 2 pi over 2, and 3 pi over 2. So I'm going to label these 4 values on my graph. And I'm going to count negative 1, negative 2, negative 3, pi over 2's, and then positive 1, positive 2, positive 3, pi over 2. All right, these are going to be my vertical asymptotes. So I'm going to draw a vertical line, lightly and dashed, through these values. Those are going to be my vertical asymptotes. That's going to be the part of my graph that my picture, my graph itself, is going to curve towards. All right, the next thing I'm going to ask you to do is I'm going to ask you to take each of these sections between your asymptotes and cut them in half and in quarters. Kind of like what we did last class. So I found my asymptotes by setting theta equal to these 4 values, and that's what theta equals. I graphed those and made those my vertical asymptotes. And in between each set, I cut it in half and cut it in quarters. All right, what we're going to do next is we're going to pick one of the sections. The left, right, or the middle, we're going to label them. Label those halves and quarters. And I'm going to do the middle, and anytime I can use 0, I'm going to want to, because the middle of this is 0. All right, so now I need to find my quarters. Between 0 and 1/2, we know that, that's a quarter. And between 0 and negative 1/2 is going to say it's a negative a quarter. So I'm going to use negative pi over 4 and pi over 4. All right, in this distance right here, this is my period length. Whatever happens in that period, which is the distance pi, which I said from the beginning, is going to happen here and here. So I'm going to draw one of these pictures and copy it into the other one. All right, to get those pictures, I'm going to take my 3 values that I just found and substitute them into my function and do the math. So I'm going to say the tangent of negative pi over 4. I'm going to take the tangent of 0 and the tangent of positive pi over 4. And I'm going to evaluate. All right, so my thought process is I'm going to draw an x and y just to do this. So I'm going to graph negative pi over 4. Negative pi over 4 is in the 4th quadrant. That means my signs are plus minus. My reference angle for pi over 4 is square root 2 over 2. Square root 2 over 2. My tangent is my y over my x. So my first thought is, okay, tangent in the 4th quadrant, I have a positive and a negative. So my answer is going to be negative. And then I'm going to take the square root of 2 over 2 divided by the square root of 2 over 2, which is just 1. So the tangent of negative pi over 4 is the value negative 1. So I'm going to go down 1 and put a point at that place. All right, so go through it again. Negative pi over 4 is in the 4th quadrant. All my pi over 4s are square root of 2 over 2, square root of 2 over 2, so I have a plus and a minus. And when I put my y over my x and I clean it up, I get negative 1 as my answer. All right, and do the same thing with 0. Tangent of 0. 0 is over here on the right side. My ordered pair on the right side is 1, 0. Tangent's y over x, 0 over 1 is 0. I'm going to put a point here. And then lastly, pi over 4 is in the 1st quadrant. My ordered pair for pi over 4 is going to be a plus plus, square root 2 over 2, square root 2 over 2, which ends up being, when I put my y over my x, I get a positive 1. All right, so those are my 3 points. So all I've done, after I've found my asymptotes, cut this section from here to here in half and in quarters, and labeled them. I took my 3 values, negative pi over 4, 0, and pi over 4, and plugged it into this function and evaluated. Now, because these are asymptotes, to draw my picture, I'm going to start close to this one, curve through my points, and end close to the other one. I am asking for 3 periods. Okay, this, what I just drew is 1. To get my other 2, I'm going to take these 3 points and shift them over to the left section. Negative 1, 0, and 1. Connect the dots. Move it to the right section. Negative 1, 0, and 1. Connect the dots. And that's the graph tangent of theta. All right, on your homework, on a test, on a quiz, I'm going to expect to see most of this work. Don't just graph it and make a basic sketch and say, yep, there, we're good. All right, so back to the beginning. We're going to find our period length. Our period length is going to be pi divided by b, which is just going to be pi. When we have a tangent, our tangent's undefined when I have a 0 in my denominator. So that means that when I have my angles to be pi over 2, my x value is 0. So my tangent's undefined at your pi over 2's. So I'm going to set this value, this theta, right here, because that's what I'm taking the tangent of, equal to 4 consecutive pi over 2's. Negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. I don't have to solve, so those are going to be my vertical asymptotes that I drew on my graph. Then I'm going to cut each section in half and in quarters, and I'm going to label one of the sections. And I'm always going to label the middle that's based off of 0. So my middle is going to be 0. Between 0 and pi over 2 and negative pi over 2 is going to be my negative pi over 4 and positive pi over 4. And those are the values I substitute into the equation, evaluate, and that gives me my points. And once I get those middle 3 points, I can copy them into the other 2 areas and use your asymptotes as guides to draw that smooth curve. All right, that's the basics. All right, let's do y equals the tangent of 2x. Y equals the tangent of 2x. All right, so my period length is going to be 2, not 2 pi, it's pi. Pi divided by 2. So it's going to take the distance, pi over 2, to go through all of my answers. All right. Now I need to find my asymptote. So I'm going to take 2x and set it equal to 4 consecutive places that the tangent's undefined. We said the tangent is undefined. It's your pi over 2, so I'm going to go negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. Now I'm going to solve all of these. So I'm going to multiply both sides by a half on all of these. So I'm going to get x to equal negative 3 pi over 4, negative pi over 4, positive pi over 4, and positive 3 pi over 4. So these are here my 4 consecutive places where this function, or this equation, is undefined. All right, so I'm going to label those now. So I'm going to count to the left. Negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4. And then I'm going to go to the right, 1, 2, and 3 pi over 4. And those are my asymptotes. So I'm going to draw a dashed light line through them. They're not part of your answer, but they are guides so you can draw the right answer. I expect to see them, but truly, if you graph it on the calculator Desmos, these lines don't show up. Next, we'll cut each section in half and quarters, and I'm going to label one section. So between 0 and pi over 4, that middle is pi over 8. Between 0 and negative pi over 4 is negative pi over 8. Now I'm going to take those values, y equals the tangent of 2 times negative pi over 8, y equals the tangent of 2 times 0. I'll move over here, y equals the tangent of 2 times pi over 8. And I'm going to evaluate. So I took these 3 values, negative pi over 8, 0, and pi over 8, substitute them in. So 2 times negative pi over 8 is negative pi over 4. Negative pi over 4 is down here in the 4th quadrant. In the 4th quadrant, my signs are a plus and a minus, so that means my answer is going to be negative. And we said on the last slide, all my pi over 4s. I have the ordered pair square root of 2 over 2, comma square root of 2 over 2 with the correct signs. So when I put my y over x, my first answer is negative 1. Then I'm going to plug in 0. The tangent of 0, 2 times 0, is over here. That ordered pair is 1, 0. So that means that this answer is 0. The last one, the tangent of 2 times pi over 8 is pi over 4. Pi over 4 is here in the first quadrant. We know the answer is going to be either positive or negative 1 since it's a pi over 4. And in the first quadrant, they're both plus signs. So I'm going to put a positive 1. Every time we do these, right, Understand, when you take the tangent of this piece, if your first answer is -1, your second answer is going to be 0, your third answer is going to be +1. That's how it works. All right, so the tangent of my first angle, I got an answer of -1. I know from now, because this is what's always going to happen, if my first answer is -1, my second answer is 0, my third answer is 1, then I connect the dots and draw a decent looking graph. And then after we draw that graph, we're going to take those points, move them to the left and the right, and we're going to be done. So I'm going to go over here, -1, 0. I don't know why my pen's having so many issues. Excuse the sloppiness, but I don't know what's going on with this. There we go, finally. And that's the tangent of 2x. We'll add one more thing to this one before we go to cotangent, and then go to the other ones. All right, 3 tangent of x over 3 plus 2. I'll put a parentheses around this just so we realize that's what we're taking the tangent of. So, my period length is going to be pi divided by 1/3, which is 3 pi. So in between my asymptotes, you're going to have the distance of 3 pi. From last class, hope we realize that the +2 is going to make it go up 2. The 3 in the front is a stretch. It's kind of like an amplitude, but it's not really an amplitude. It's my stretch. All right, so I'm going to set x over 3. Equal to my 4 consecutive asymptotes. And then I'm going to solve each one. When I have a tangent, it's always going to be these 4 values, -3 pi over 2, -pi over 2, pi over 2, and 3 pi over 2, solved for x. So I get 9 pi over 2 on the bottom, 3 pi over 2, -3 pi over 2, and -9 pi over 2. I'm going to label these asymptotes now. So I'm going to go -3, -6, -9 pi over 2. Then 3, 6, and 9 pi over 2. These are my asymptotes. Not the prettiest, but they'll get the point across. All right. Each section needs to be halved and quartered. Now I'm going to label the middle. Half from 0 to 3 pi over 2. 3 pi over 2 divided by 2 is going to be 3 pi over 4. Which makes this one -3 pi over 4. I'm going to move this up a little bit because I know what happens. All right. We are going to take that first value and substitute it in. So I'm going to go 3. Let me get a different color. Y equals 3 times the tangent of -3 pi over 4 divided by 3 plus 2. -3 pi over 4 divided by 3 is going to be negative pi over 4 plus 2. We've done this twice already. Negative pi over 4 is down here. My tangent is negative, and the tangent of any pi over 4 is 1. So this piece here becomes a negative 1. Now I finish my math. I get negative 1, so I'm going to put my first point down here. All right, there's my first one. All right, now my second and my third. We're going to kind of do less work this time. When I took the tangent of my first one, I got an answer of negative 1. So that means my second one and my third one are going to be pretty simple. So if this first answer is negative 1 like it was here, my second answer is 0. So I'm going to put a 0 into the tangent part, and then I'm going to put a 1. 3 times 0 plus 2 is 2. So there's my next point. Put a 1 in, and I'm going to get a 5 as my last point. So once you verify that your first answer in relation to the tangent part gives you an answer of negative 1, the next one automatically is going to be 0. The next one's automatically going to be 1. You can plug the math in and do it, but you don't need to, understanding that's the pattern. So this is my graph, and I'm going to copy it 2 other places. All right. For this one, because of my vertical movement, instead of being at 0, it's at 2. And the distance in between my points is 3 instead of the 1 that has been. So that's 3 tangent of x over 3, add 2. Right, cotangents can be similar, just a little bit different. All right, for cotangent, it's cosine of theta over sine of theta. So this time, the cotangent is undefined when my sine of theta equals 0. All right, so I need to know when my sine of theta equals 0. So on the left and the right are my order pairs 1, 0, negative 1, 0. And that's when my y value is 0. At 0, pi, 2 pi, 3 pi, 4 pi, and it keeps going. So we're going to say that the cotangent is undefined when theta equals 0 and all of your pi's. So we're going to say when theta equals your zeros and your pi's. So for this one, my period length is pi divided by b, which is 1/4, which means 4 pi. So in between my asymptotes, I'm going to have the distance 4 pi. Now I'm going to take x over 4, set it equal to 4 consecutive places where the cotangent is undefined and 0 and pi, so we're going to use negative pi, 0, pi, and 2 pi. You can use 7 pi, 8 pi, 9 pi, and 10 pi if you want, but it's going to make your graph way different. All right, so I'm going to solve all these by multiplying by 4. And get negative 4 pi, 0, 4 pi, and 8 pi. So those, negative 4 pi, 0, 4 pi, 8 pi, are going to be my vertical asymptotes. It's different because I want to know when y equals 0, and y equals 0 on the left and right. Why do I have these as my verticals? They've shifted. I'm going to pick one section to label. I'm going to pick between 0 and 4 pi, which we know should be pi, 2 pi, and 3 pi. So I'm going to take that first value, pi. I'm going to go to cotangent of pi over 4 for this first one. All right? So cotangent is x over y, which doesn't make a difference if it's a pi over 4. This is in your first quadrant, where my answer is going to be positive. And all my pi over 4s for tangent and cotangent, since my ordered pairs are the same, I'm going to get an answer of positive 1. Oh, not there. Here. So when I plug in the next one, the cotangent of 2 pi over 4 and the cotangent of 3 pi over 4, using the same idea as my pattern. If my first answer is a positive 1, because this is going to be the cotangent of pi over 2, at the top, my ordered pair is 0, 1. When I put my x over my y, I get an answer of 0. 3 pi over 4 is over here in the second quadrant. So that tells me my cotangent's negative, because I'm in the second, and my signs are different, and it's got to be negative 1. So for these, for a cotangent, once you get positive 1 as your first answer, your next answer is 0 and negative 1, adjusted if you have numbers before and after. So I get these 3, and my graph's going to go the other direction because it's a cotangent. Copy it into the other pieces. And that's the cotangent of x over 4. All right, so my main idea, most important concept, is finding these asymptotes. You've got to be able to find it for tangent, cotangent. Cosecant, secant is going to be a little bit easier, but we'll get there. All right, cosecant and secant. All right, secant of theta is 1 over the cosine of theta. That tells me that the secant of theta is undefined when my cosine of theta equals 0. So when my x values are equal to 0, and again, that's the top and the bottom. Cosecant of theta equals 1 over the sine of theta. So the cosecant is undefined when the sine of theta equals 0, which means my y's are 0, which we said are 0 and pi's. So when I'm taking the cosecant of a 0 or a pi, it's undefined. When I take the secant of any pi over 2, it's going to be undefined. All right, and for secant and cosecant, we're going to go back to 2 pi over b. So we're going to graph the cosecant of x. And what we're going to do, we're going to do this a little different. And we're going to show how it works when we do this. All right. So the way we're going to do this, my period length is going to be 2 pi divided by 1, which is 2 pi. All right, so to get through all my answers, I have to go to distance 2 pi. But when we graph a cosecant, what we're going to do is I'm going to end up graphing 1 over the sine of x. All right, so we're going to graph 1 over the sine of x. So I'm going to change this, and I'm going to graph the sine of x instead. And then we're going to adjust it from there. So I'm going to graph the sine of x. All right, this has a period length of 2 pi by amplitude of 1. And because it's just x, my graph is going to start at 0 and go out to 2 pi. All right, it's going to start at 0, and it's going to go out to 2 pi, because that's my period length, and I don't have any shifts. I'm going to cut it in half and cut it quarters, and I'm going to take it a few more places. Just a handful each way, probably about 3 each way is going to be good. All right, and we're going to label this one section. Pi over 2, pi, 3 pi over 2. And this is last night's homework. So I'm going to take the, not cosine, I'm doing sine. The sine of 0, which is my first one. 0 is over here on the right. That's ordered pair 1, 0, so the sine of 0 is 0. So at 0, I'm going to have a point at 0. All right, then I'm going to take the sine of pi over 2, which is at the top, which is an answer of 1. The sine of pi, which is on the left, and my y value is 0. And because we did these and know these, we can tell if I go from 0 to 1 to 0, my next answer is negative 1 and then 0. I'm going to go 2 more points both ways. Okay. So lightly, I'm going to draw this one. This is not part of your answer. All right, so I'm going to draw this. All right. That's not part of our answer, but it's going to help us. All right. We said whenever the sine, let's go back to here, whenever the sine of theta equaled 0, I had an asymptote. So what I'm going to do, everywhere that I have an answer of 0 for sine, all my middle points, I'm going to draw vertical asymptotes at all of my zeros, all my middles. Then, because this is the reciprocal, to get the graph that I want as a final answer, what we're going to do is instead of having this wave, we're going to have parabolas. So these are going to be vertices of parabolas that we're going to draw. This one at the top is a parabola that opens up. These at the bottom are going to be parabolas that open down. All right, that's what I'm going to want to see is 3 pieces. Just to understand the math behind it, just understand when I take the reciprocal of this wave, it's going to flip it over. So my high points are going to be parabolas that go up. My low points are going to be parabolas that go down. I want 3 pieces. So you need to draw your sine graph as many times as you need to give me 3, or give me, let's do it this way, 4 consecutive asymptotes and 3 graphs. If you want to draw another one, this one will go up. But cosecant and secant are going to be parabolas that alternate going up and down, that never intersect each other horizontally. There's going to be a gap. So we're going to graph the sine function for a cosecant. All your middle values are going to become vertical asymptotes. All your highs and lows are going to be vertices for a parabola. Highs go up, lows go down, and this is the graph of y equals the cosecant of x. I want at least this from here to here and everything in between. So if we knew how to graph sine and cosines, cosecants and secants are going to be pretty easy. Your middle points become middle points become vertical asymptotes. Your highs and your lows, your relative mins and maxes become vertices of a parabola. Highs are going up, lows going down. So we've got to be able to graph this if we want to have a chance to graph cosecant and secant. All right, last one. Y equals the secant of 2x minus 1. All right, so this one's going to shift it a little bit. So that's not a big deal. We'll take care of that. So I'm going to graph, let's do it this way. My period length is going to be 2 pi divided by 2. It's going to be pi. I'm going to change this into a cosine problem. And I'm going to graph that. So my period length is going to be pi. My amplitude is going to be 1. This is a vertical shift, so I don't have to worry about it. So I'm going to start at 0. Go out to pi. Cut it in half and cut it quarters. And I'm going to draw a couple more values each direction. I'm going to label from 0 to pi. Like we did for homework. And then I'm going to plug those values into here. So I'm going to go y equals the cosine of 2 times pi over 4. Oh, I skipped one. Let's start with 0. 2 times 0 minus 1. So I have cosine of 0 minus 1. Over here on the right, my ordered pair is 1, 0, so the cosine of 0 is 1 minus 1. Gives me my first answer of 0. I'm going to take my second one and plug it in. Y equals the cosine of 2 times pi over 4 minus 1, which is the cosine of pi over 2 minus 1, and pi over 2 is at the top, which is the ordered pair of 0, 1, so the cosine at the top is 0 minus 1, gives me a point at negative 1. All right, doing one more. Y equals the cosine of 2 times pi over 2 minus 1, which is the cosine of pi, subtract 1. Pi is over here, which is negative 1, 0, so the cosine of pi is negative 1 minus 1. Gives me an answer of negative 2. And once I get 3 points, I went from 0, negative 1, and negative 2. My answer is going to be negative 1, then 0. Negative 1, 0. Going the other way, negative 1, 0. My middle points now are going to become, because I want to know when this was 0, my middle points are going to become, put it in the wrong one, go back one. Middle ones are going to become my vertical asymptotes. Then all I'm going to do from here is my high points are going to become my vertex of a parabola that opens up. My low points are going to become the vertex of a parabola opening up. That's y equals the secant of 2x minus 1. Middle points become your vertical asymptotes. High points become the vertex of a parabola that opens up. Low points can be the vertex of a parabola that opens down. All right, and that is our section. So we have to be able to graph these. At any point you need help, you can come to tutoring. You can send me an email. You can ask me a question. All right, have a great day.